Assalamu alaikum. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. My name is Fahad Nasir. I'm an application engineer in quality solution, and today we are conducting a webinar of 2 hours on bring your scan data to CAD with surface modeling. So in this webinar, we will cover about the reverse engineering, and we will talk about the software designs, geometric design next software, in which we will show you the examples how to convert the mesh data into a CAD model. So in this webinar, we will talk about how to edit the mesh, how to enhance and modify the mesh data, how to create the regions on the mesh data, and how to create the contours and the curves network or patches on the mesh data. So with the help of that contouring, we will make the freeform surface body, and we will also create the some features, modeling features such as pocket features, revolve features, and the holes. In the end, we will also compare the result, our CAD data with the mesh data, and we'll show you guys the deviation, how much it has been deviated from the original mesh data. So those of you guys who will attend this webinar of 2 hours, they will be awarded with CPD points of 0.5. And in the end, they will get this certificate. And with the help of this certificate, they can redeem the CPD points from Pakistan Engineering Council. So this webinar is the continuation of this series, which we have started almost 4 months ago. And we have covered so far various topics, such as essential courses, in which we talk about the solid modeling, assembly, and the 2D drawings. We have also covered the surface modeling and 2.5-axis milling CNC operations. We have already discussed about the reverse engineering, but in the previous webinar was on the solid modeling. So today we are focusing on the surface modeling. So all of these webinars that we have already conducted, you can find the recorded webinars on our Facebook pages as well as on YouTube channels. So we are Quality Solutions, and we are representing various CAD CAM softwares in Pakistan. We are also representing 3D printers and 3D scanners, and our presence in Pakistan are in Karachi and in Islamabad. If you guys need information about CAD CAM softwares, or if you guys need training, you guys can visit us or you can contact us to our office. So reverse engineering. So this reverse engineering is used in various fields. It is used in the IT field, it is used in the electronic field, as well as in the mechanical field. So both have the same understanding that if we have some product which has been manufactured, how we can get back to the initial documentation, initial information. So let's say in case of the reverse engineering, we have this workflow in which we have the idea or the concept of the product. And then we, with the help of detailed designing, we come about the 3D model and the 2D drawings, and we perform the simulation and validation. So after confirming the 3D model, we go to the manufacturing process or the prototyping process. So in the end, you will get the product in the market. So let's say if we have a product and we want to go back to its original initial information, like what are the 2D drawings and where is the 3D model. And if we don't have this information of that product, so we have to use reverse engineering in that sense. So basically we have product, we will reverse it and get the initial information such as 2D drawings and the 3D modeling. So there are various methods used for reverse engineering in mechanical engineering in a mechanical field, which range from the manual measurement method to the 3D scanning and 3D scanning methods. So in this webinar, especially the quality solution, We have expertise in 3D scanning services. We have 3D scanners, and most of the time we perform the reverse engineering process with the help of 3D scanners. So in case of 3D scanner, let's say we have a handheld 3D scanner, and this scanner is a laser based. There are various other technologies in 3D scanner, such as photogrammetry, which take the pictures, multiple pictures of the object at different angles, and then combine them together to make a model. So in case of 3D scanning, it actually how it works is basically the laser is basically it is transmitted from the scanner, strike the object, and come back to the scanner, and it is received. So that each laser, there are segments of lasers. It capture the information in a coordinate form. So, and the laser is capturing millions of coordinates in seconds. And with the help of these coordinates, we are able to come to the mesh data and the final CAD model. So there are different technologies used in the 3D scanners. There are red lasers, there are green lasers, and the blue lasers depend on the wavelength and also increase its accuracy of capturing the data. Then the output of the 3D scanner is in the two form. One is the point cloud data, and another one is the mesh data. So point cloud, as the word represents, that it is the cloud of points. So basically these points are the coordinates of the object in X, Y, and Z directions. And there are millions of points, so we call it point cloud data. So with the help of point cloud data, we get the mesh data as well. So there are softwares which come along with the 3D scanner that will convert the point cloud data automatically into mesh data and give us the live mesh result while we are scanning the object. There are various applications used in the reverse engineering and many various purposes as well. So, and it has been evolved along with the time and along with the advancement of technologies, the application of it. So we can use the 3D scanning and the reverse engineering for 3D printing. Once we have scanned the object, we have the mesh data, and then we can go simply for the 3D printing without reversing it. We also use reverse engineering application for redesigning and modification. Let's say we have an object and we want to modify it. Let's say there are 10 holes and we want to make it 5 holes. There are grooves, there are slots. We want to remove those grooves and slots in the CAD model. So we perform the 3D scanning on the existing object and then get the CAD data and then modify it accordingly. So the reverse engineering is also used to find out the areas and the volumes of the complex parts, such as the interior of the car and the vehicle. It's very difficult to find out the interior space, exact measurements, and the volume it enclosed. So it's very difficult to use the conventional methods. So 3D scanning and the reverse engineering is very suitable to find out the exact area and the volume of the interior of the body of the car. Then we can also use the reverse engineering for designing of dependent parts. So there is one part that is available and we have to link this part to another part. So that's how it will be useful as well. And it's also used for documentations, such as for 2D drawings and for making the isometric views, for making the third angle projection and first angle projection. So the reverse engineering is also used for digitizing the existing object. Let's say we have the part available in our workshop, and we already know that the company who is manufacturing this part, they are long gone, and they are no longer manufacturing that part. So we can secure that part in a digitized world. We can 3D scan it, make a 3D CAD model of it, and secure it in our storages. So once we need in the end, we can get the information and start the manufacturing or machining process. So 3D scanning or reverse engineering is also used for making the models. which are used in the animations, in the movies, in the games, in the animated cartoons as well. So this is the first example. We will try to focus on it, and I will show you how to make this joystick. We have a joystick, and we have the mesh data and how to convert this mesh data into a solid model with the help of auto surfacing in this software, the geometric designing software. So in this example, we will go through the mesh editing, how we can edit the mesh, modify it, enhance it, and we will also talk about how to create the regions. These regions are like the software has the capability to analyze the mesh data and find out where are the primitive shapes, like such as planes and surfaces. There are some cylindrical shapes, some conical shapes as well. And then we will also align the mesh data with the default references of the workspace. And then we will go to the auto surfacing, in which we will create the contours and create the solid model, and then perform some features such as hole and pockets on it, and then analyze the final solid model, and we will see how much it has been deviated from the original mesh data. So this is the point cloud data of the joystick, which is captured by the 3D scanner. And you guys can see there are so many points there, which represent the actual geometry of the object. So these are the coordinates, and which are placed in the workspace based on the origin, and they have the information of X and Y axis. So with the help of this point cloud data, we get this polygonal structure in which we have the triangles. So all the points, and they are interconnected to each other, and they form a triangle of three vertices. So then with the help of these structure, we get the mesh data. So in the mesh data, we can see these triangles, and they are filled up with small surface, and the combination of the whole small surfaces give us this the whole object result. So this is the mesh data, and if we remove the links, we can see the surfaces of the mesh only. And with the help of this mesh, we can able to find the information. We can make the 3D CAD model. We can apply solid modeling and surface modeling. So we have the workspace of geometric software, and we are in the workspace, and there are default planes which are perpendicular to each other. And on the right hand side, we can see there are some feature tree. So if we apply some features, solid features, revolve command, extrude command, it will be appear on that section. And then at the bottom, we have some default planes. We have reference plane, we have the reference coordinates. And if we start to make a solid modeling, we will have a box for the solid bodies only, and we will have surface bodies. I will show you in this example as well. So on the right hand side, we can see the properties. We will see the properties of the mesh data or the solid body, the appearance, what is the visual effect. We can also see the accuracy toolbar and the display toolbar. So I will also explain you guys step by step what would be the benefit of these tools. So let's import the data. We go to home toolbar and click on the import and get the file. So this is the STL format file of the joystick, and it has been placed in the workspace based on the coordinates of the 3D scanning. We can see the workspace have a reference plane, top view, a front plane, and a right plane, and they are not properly aligned with the joystick. So we have to apply the alignment manually for this one. So I will show you as well. So let's hide these planes for a time being. Before begin with the solid modeling or surface modeling, we have to understand the mesh data or the object, what type of features it requires, where we have to apply the solid features or surface features. So in this situation, since we are using the surfacing only, so we have to look at like surface are not very good for the sharp corners and for the solid bodies, solid objects. So for to simplify the mesh data, I will try to modify this mesh data by removing the circles and the top button of the joystick. So yeah. So another thing is for the auto surfacing, this software has a good feature to create the auto surface automatically. So for that, we have to clean up some of the regions that are very sharp, that would be difficult for the auto surface tool to create the features by itself. Therefore, we have to analyze and remove those sections. So we can see this is the bottom section, and we will try to remove it. And this hole we will also try to patch it up. So let's orient the object and make a clear view of it. Yeah, that's better. So we have various tools for the selections in the top. So we have this line tool for the selection, this rectangle tool for the selection. So let's say, so with the help of this rectangle tool, we can select the object in a rectangular shape. And with this circular one, we can select in a circular shape. So depend upon the application and depend upon the geometry, we vary the type of the selection. This is also a polygonal tool for the selection. So let's select the rectangular shape to select the bottom region of the mesh data. And then just simply click and drag, and it will select the bottom region. It shows in the light blue color. All right. So we have another option at the top is the visible only, and it is right now unchecked. So if we check it, so and try to select the mesh data, we can see that it is only selected which was visible in that view, and at the back hand side the mesh data was not selected. So and that's why it's called visible only, and which is not visible, it won't be selected. So since we want to select the whole region at the bottom, we will uncheck the visible only option and reselect that bottom region. By unchecking it, we are able to get the selection, and we can just select the line and press the control button with the visible only checked. We can able to unselect those areas which are not needed. So just simply press the control button, and then we can see the minus sign beside the cursor, which shows that we are unselecting the selected area. So once we are sure that this is the area we want to select and remove, we can just simply press the delete button and it will remove the bottom region. We can see some sharp edges. There is an extra patch there, very small tiny patch. So just remove it with a normal rectangular selection tool. Just simply click and drag, select and press delete button. So we have the bottom boundary is quite sharp because of the polygonal structures. It is made up of the triangles. So we go to the edit boundary feature and then select the lower boundary. The whole edge will be selected automatically. And then in the method, we can select the smooth option. So with the help of this smooth option, we will get some smoother result at the boundary edge. So the shaded region shows the reference, or we can increase its intensity as well. So just make it okay, and then we have this smooth boundary, and better smooth boundary as compared to last time. So now we want to extend this boundary. So this Geomagic have great tools to improve the matched data, to modify the matched data, and we can simply press the extrude button there and then put the value of 3 mm. So we have selected the boundary and we will get the matched data which would be extended toward the bottom to 3 mm. So yeah, so it would be attached with the previous match data as well. So just by pressing the check option, we get this mesh data extended and now is quite smooth and completely planar. Yeah, so that's how we can improve the mesh data. So this is the whole we don't need in our auto surfacing feature. So we try to select it with the polygonal feature, and then we can simply press the delete button and we will get the whole deleted. So there are some patches in the middle, we can also delete it. All right, so we have the edge of the hole, and it is same. We apply the boundary features to make it smoother. Now we are going for the fine fill hole. So what it does, we can just simply click. We have to select which mesh data we have to apply changes, and then click on the boundary. Click the boundary, and then we can um, view the result, preview the result before going to check it. So we can see the appearance that that's how it will fill up the hole. And since we also apply the curvature settings, we can go for it, and the hole has been filled up. We can see some boundaries, sharp boundaries that shows that there are some features applied. So we can use the smart brush option, which is also available in the polygon tab. So we can apply and then smoothen down the boundaries. So it depends on the clicks. If we select the region and click multiple times, it will get more smoother. Yeah. Similarly, we can go to the top and we have this. I think there is something. Yeah, we can select this hole and then use this circular selection tool to select the top hole, and then press the delete button. Yeah, since it is the visible only option was not checked, so it also selected the bottom region. So we want to unselect it first and make sure that only this top hole has been selected. So we can simply press the delete button and delete it. And we can just make sure that the selection is only to the area where we want to remove, and it should not remove extra profile. So we try to unselect those regions. All right, so I think that's better. So we can just simply press the delete button and then delete it. So also we have to smoothen down the boundaries. So we just simply click the edit boundaries, click the edges, and then click OK. So the boundaries has been smoothened down. And then we go to fill hole option, select the hole and click the preview and see how the hole will looks like. So it's not going off from the main surface. This looks good. We also have the outer edges, which shows the prominent difference um, from the fill-up hole and the normal mesh data. So we will apply the same smart brush tool to smoothen down the mesh data. All right, once we are sure that nothing is very obvious and there are no sharp edges, um, we are good to go. So now we can also see the patterns of the mesh links. Here we can see the artificial patch-up that we just created. I couldn't able to show you just to save the time. So that was slightly different from the normal mesh links. So we can see the artificial links were very smaller in size as compared to the normal mesh data. So this might affect our 3D modeling process and our contouring process. So we, in the end, we will try to make it or the whole mesh of same pattern and same sizes. So if you look at the behind, you can see this is the pocket in that object, and we want to fill up this pocket since in auto surfacing such type of the empty spaces and the empty patches are not very good to work with the auto surface. Therefore we try to fill it up, and first we have to select and delete this portion. So we use the normal rectangular selection tool and then select this region and just go to the top, and there are some extra region which was also created selected. So we just check the visible only and then press the control button and then remove the selected area from the sides as well, and little bit right from the top and from the sides. So we select this line tool and then unselect the region. All right. So now, and this one seems better. We can delete it, this region, and try to fill this up with the mesh tools that are available in the software. So we go for the same process. First select the edit boundaries and then smooth the edges. So we can increase the intensity and then smoothen down as well the edges. All right. So now since and this one is a big patch and it's difficult for the software to fill it up with a normal method. If we just simply click the boundary and try to fill up this hole, we can see the results are not as what we require, and it's make a bad profile in the end. So for this one, we try to make bridges, try to fill up this patch with small bridges like a stitching method. So we select the editing tool and there's option edit, add the bridge, and we select the vertices on both sides and then try to make a bridge to cover up the whole patch. So we are able to completely fill up the patches, and then we go to the edit boundaries and select the fill option and select the stitching, all the stitches we just created, and then it will fill up the boundaries automatically in a more better way as we required as compared to just fill up the whole patch. So this process takes some time, so I have to shorten down the video, skip some portion of it. Yeah, so we can see the result. These are the yellow portion are the automatic meshes that are created based on the stitches and the bridges. And we can also see some wrinkles and some sharp bends. So we try to smooth this profile with the help of smart brush. So just use the smart brush, and in the method it is smooth, and in the option the strength is maximum. So let's try to make it smoother in the first click as possible. So it will take some time to get the smoother result in this scenario. So we try to focus on those regions which are a little bit sharp, have some wrinkles as well. All right, so the on the surface, the mesh data has been completely filled up, and there are no extra patches there, and it's also smoothened down. Now, in this one, it's time to enhance the structure of the mesh. We can see the holes are completely filled up. There was also a button at the top. We also remove it and also completely patch it up. So these are the connections or the links of the mesh data polygonal structure. And we try to make it similar and constant pattern throughout. So for that, we have features in the polygon tab. It's called global mesh. We can use these global mesh features on the mesh data and get the result, which is more constant and similar pattern, like the sizes of the triangles are constant throughout. We can also see at the behind that we just fill it up. There are small triangles there. So such type of information really affects the designing capabilities of the CAD designer. So let's go to the global remesh and then select which mesh data we have to redefine the patterns. So we can just simply set the setting as it is, depend upon the size of the triangles, and then see the result. Sorry guys, there was some problem in the displaying the screen. So let's show you guys once again where we just ended. So we had the match data, and we wanted to make a new pattern with the constant appearances. So we just simply go to the global remesh and then select the mesh data and go for it. And here we can see the result. We can see the polygonal structures, and the pattern is now constant. The sizes of the triangles are constant all over the mesh data. This really enhance the capabilities of the contouring. It shows the smooth results in the end, also in the surface modeling. So once we are sure that our mesh data is completely ready for the auto surfacing, we can jump up to the auto surfacing method. Here we have the mesh data ready. Um, in this step, we want to align the reference planes. The reference planes are very important for CAD modelings because it shows which is the top view, which is the right view, and which one is the right left view. So based on these reference plane alignment, we can able to generate the 2D drawings. And once we have completed the 3D CAD modeling without alignment, we cannot realign the CAD data. It's very difficult for the softwares to realign the CAD data's reference points. So for that, I will try to utilize the features available on the match data to create to make the alignments. And there are various methods we can use. We can make the regions created on these match data and then extract the information for the alignment. Since we have already smoothened down this match data, we will try to import a new one and the same file, and it will be placed in the workspace in the same location. So we can see the orange mesh data is a new profile, new file that we have just imported, and the blue one is the existing one that we have modified a lot based on our requirements. So we will select the orange body and try to select those regions which are needed for the alignment and also for making the manual modeling. So the middle section of the joystick is not needed for the alignment, so we just need to simply remove it to reduce down the size of the file. So in this specific view, we can just select the rectangulars selection. And then just simply use the delete button to remove the middle portion of the joystick. So we also uncheck the visible only to select the whole portion of the middle of the joystick and then remove it. So now it's time to create the regions. We can go to the region tab and select the auto segment and then change the sensitivity accordingly. So let's say we want to make it around 20. So what it does is basically create the it divide the mesh data into small regions based on the primitive shapes, and we can able to extract the informations very quickly. So you guys will see the result. So this is how the regions have been created. You can see multiple colors there, and the green color for the plane, and the blue color which shows the conical shape, and the light green which shows the spherical shape. So once we are good that the proper regions have been divided, we can just simply hover over the mouse on those regions, and it shows us that this is a plane region and this is the cylindrical region. So this information really help a lot in making a CAD modeling and performing the reverse engineering without wasting any efforts. So for the alignment, I will just rewrite the name of the new mesh data not to get confused with the similar names of the previous one. So on this data, I will create some, I will use the regions, and I will use these regions for the alignment. So I will go to the alignment tab, and in the interactive tab, I will select the mesh data, which mesh data I have to align. So for this, I will use both of these since I want to get the CAD model from both of these two mesh data from the same origin. So I will select both of these two mesh data, and there are two methods used for the alignment. One is 3-to-1, in which we have to show the plane, vector, and position. This one I will show you in the next example, but for this example I will go for the XYZ method. So I will select the XYZ method. In this method, I have to first assign the position of the origin, and then I will show which is the direction for the x-axis, which one is for the y and z-axis. So I would need 2 or 3 information I have to insert, and then I will get the alignment. So in order to show that where is the origin, I will select the plane and I will select the cylindrical region. So the center axis of the cylinder and the plane will intersect into each other, and that would be the origin for our default planes. So we can see that origin has been shifted down to the bottom, and now we have to assign the direction of the x-axis. I want to make it toward the left-hand side of this small tube coming out. So I will select this region, and we can see the x-axis has been aligned parallel to the axis of this tube. So the direction is opposite, so I can just simply click on the arrow and get the direction in the same as the direction of the tube. Yeah. So this is the x-axis moving toward the left-hand side. Now we can select the z-axis, which I want to make it in the upward direction. So I will select the plane at the bottom, this one, and we will see that the z-axis is now normal to the plane. So it's going toward the down. I want to make it in the opposite direction. So I just click on the arrow and the z-axis have been shifted toward the top, which we can see on the right-hand side screen. So the x-axis is along the tube and the z-axis is normal to the bottom plane. And the y-axis direction is perpendicular to x and z. So once we are good with the alignment, we can view again the reference plane and we can see that now they have been aligned properly based on the mesh data. So this plane is we can have the top plane at the bottom, the front plane and the wide planes. So once we have gone through the alignment process, it's time to start with the outer surfacing. So everything has been cleared, the mesh data has been modified, the patches have been completely filled up, and the alignments, the reference planes are also on the proper location. So let's start the auto surfacing features, and then in the end we will check the deviation. So go to the extract surfacing tab, and then in that we have the auto surface. So we can select the which mesh data we have to use. So we are using this blue color one. So it's auto, the name is auto surfacing. So we select this blue color mesh data, and whether we want mechanical component or organic component. Since it's a joystick, it seems like a mechanical, so we go for mechanical one. And then there are some options for the accuracy. So basically this auto surfacing will give us the contours and as well as the patches on the whole mesh data. So we go to the next step and wait for the final result. It will take some time. So here we can see the contours have been generated automatically by this command, and we can see the small patches. What is so important about these patches that they consist of 4 vertices. Every patch consists of 4 corners, and if we don't have a patch of corners equal to 4, we won't get the surface filled up to that patch. So we have to completely analyze, and this software with the auto surface, it will generate the patches with 4 corners. So with the help of this deform option, we can readjust the corners based on our requirements. We can move around the contours up and down and try to make the profile more smoother and more accurate. We can see at the top the outer orange color profile is not completely on the edges, so we try to fit it there. So, and this process might take long time because since it is computer generated, we have to look at each patches carefully in order to get the good result in the end. So for this demonstration, I will leave the patches as it is, and I will show you the what would be the end result of these contours and patches. So we can just simply go for it, click OK, and it will process these patches by trying to make small surface on each patch. So that one patch consists of one surface. So there are a lot of surfaces there. They completely join to each other. And since it is a closed patches is closing to each other, So all the surfaces which are created are also closed, and this closed surface automatically convert into a solid body. And we can see on the right hand side, it shows it is a solid body, but it's actually made up of surfaces, lot of surfaces. So just for the demonstration, if I remove one single patch, I can able to get back the surface from the solid body. So we can see at the bottom as well, there is no holes, there is no gaps, everything has been completely filled up, and that's how it represent, give us the solid body result. So just to show you guys that whether we can able to convert this solid into surface, we select this one patch and then remove it. So go to the model, and on the right hand side, we have the delete face, and then click one single patch and click OK. So here we are able to delete the one single patch. So as soon as the patch has been deleted, there is a hole and gap created between the surfaces, and it automatically converted into a surface body. And we can see on the right hand side. So everything was filled up only except on this patch. So that's why it converted into a surface. We can fill it up this surface by selecting the boundaries by using the fill face tool and click OK, and it will then again bring back us the solid body. So I hope you guys know what is the difference between the solid bodies and the surface body. I have already covered this one in my previous webinar. Mostly the surface body, they have the thickness of infinitely small, very small thickness, almost reach to zero. And a solid body, they have thickness. This is one of the basic way to differentiate. So we have this another tool, deviation analysis tool, and we can see by pressing it, we can able to see the color map on the object. And on the right hand side, we can see the bar which shows what is the meaning of different colors. So the green region shows that it is 0.1 mm accurate, plus minus 0.1 mm from the mesh data. So if we reduce to 0.05, we can able to see some small regions which have accuracy less than plus minus 0.05 mm. So this is a great tool that help us to keep our solid modeling within the limit from the mesh data. So if the requirement is that our CAD model should not deviate from the mesh data around 0.1 mm, we can able to verify it with the help of these tools. So there are different tools available in the software. We can also check the continuity of the surface. We have this zebra strip option in which we can see the tendencies of the surface of the body. So whether the surface is smooth or not, or whether these surfaces are tangent or not. Since it is auto surface and everything has been tangent with each other, so we can see there is a small shift of the zebra strips as we try to move up and down. So there is no abrupt changes. There is no separation line there. A complete smooth change toward outer to the middle, or from middle to the out, based on the movement of our model. So with the help of these tools, we can also analyze the surfaces, because it's very difficult to control the surface. Sometimes there are some dents there, some there are pop-up outside. It's difficult to view, but with the help of these tools, we can verify our surfaces. So once we have a solid body there, we can then proceed to the further actions. If you look at the original mesh data, they have some revolve features at the bottom, and there are some holes there. There is some pocket, some holes for the buttons. So the rest of the body we have achieved with the help of auto surface, but and these sections, this conical and the cylindrical sections, we have to create manually. So I will show you as well how to create these features. Also to create this pocket there at the behind, if I hide the blue color mesh data, we can see on the original data there was this pocket. So I have to create this pocket in my solid body. So this is also a button. Since we know it is the assembly, this button is not a part of the actual body of the joystick. So we can simply remove it and don't design it in a part modeling. So we also know the difference between the part and assemblies. And assemblies basically they are the combination of the two or more parts. So this scan data is the assembly. It consists of more than two parts. So we try to make a solid modeling only the body of the joystick. So for the bottom regions, we can make it with the help of revolve features, and for that, and we know that it is the cylinder. And for the cylinder, what is important is the central axis. So we can go to vector and select the find central axis, and then click on the region, and we are able to get the central axis of that cylindrical region. So with the help of this vector, we can able to align the plane for this cylinder and create a new sketch, and then revolve that sketch about this central axis. So we can go to plane and then select the plane as a reference, and then click on the vector, which is the axis of the cylinder, and the new plane will be created, which will be parallel to the and coincident with the central axis of the cylinder. So we hide all of the rest of the planes and default planes. So the vectors is also shown here on the right hand side. We can see everything has been combined to each other. The reference planes are together. The reference axes are together. The solid bodies are on the one side, and the mesh data is also one side. So it's completely organized and arranged in a proper way, so we can easily differentiate and hide and unhide it. So we simply select the plane and then go to the mesh sketch, and under the sketch we have the mesh sketch option. By pressing it, we can able to see the blue color tracing on the mesh. So this is basically generated by this software. What it does, it create the traces of the mesh which are intersected with the plane that we just created, and on which we have to apply the 2D sketching. So this is the great tool for making the sketch. There are other softwares, reverse engineering softwares, and I couldn't able to find such features in other software. So GeoMagic is really efficient in these type of reverse engineering. So we can also move around the planes, and since it is a cylindrical plane, so we have to stick with the central axis. So we keep the plane to zero, the offset is zero, and then once we are sure that the blue line is more smooth and accurate to where we have to start the sketching, we just click OK, and it will bring us to the sketching mode. We press this normal 2 icon, and it will bring us back to the normal view mode, which is normal to the plane that we just selected for the sketching. So the blue color basically shows the traces of the mesh data that was highlighted in the previous one in the light blue color. So these are the traces. So this gives us the good reference point to start the sketching and do the tracing over it. So now this is a solid body as well. We can also see is completely at the bottom of that solid body. So There is also the revolve feature. Since we want to make the revolve feature, so I will create the sketch in a way that it intersect with the solid body. So I will tell you the reason why I am going to do like that, because it will give me single solid body in the end. There won't be any two separate solid bodies. So I will go to the line, select the line, and it's very helpful. We can just simply select the trace pink color, and it will automatically create the line on it by itself. So it saves a lot of time. So since it is a revolve features, I won't go to the bottom section to make a sketch. So it's a revolve features. I will make only half of the sketch and then do the revolve command to rotate that profile about the central axis. So we can see the lines have the green color at the ends and they are small dots. If we go to the accuracy analyzer on the right hand side, we can see that these joint ends are checked. So if we uncheck it, we can see the green color, they just disappear, the dots. So basically these dots shows that the lines are not connected to any other line. So if we connect them to each other, the green color will disappear. So first we try to fix these sketches. We want to keep these sketches on same place, and then use a string command to remove the extra lines. So now there are three lines that are connected. In the middle, there are two dots. So they are not in green color. That show these are connected. And only at the outer side, there are green color dots. It means they are not connected from the outside. So we will find the outer end and draw a close profile. For the solid, we know that the solid require a close profile. There should not be any open ends. Otherwise, we won't be able to get the solid modeling. So whereas in case of surface, if even the sketch is not closed, we can still able to perform the surface features. So now this seems better, and it's completely, and the bottom sketch is touching to the central axis of the cylinder. So we have the sketch. We can apply the revolve feature command and then revolve it about the vector one. So go to the model and select the create solid revolve features and select the axis, which is this vector one, and then it will revolve the sketch to 360 degree, and we will have the solid body. So we have here the two solid bodies. They are still interconnected. They are still intersecting this new solid body we just created and the previous auto surface. The reason I can make it merge together by just checking this option merge in the revolve, and now the two solid bodies have been converted into a single solid body. So sometimes we need to keep them apart, depending upon the complexity of the model. Sometimes we have to apply some operation on a one single body and then don't want to disturb other single body. So this also give additional option in this software. So now here we have to create a pocket, and we can see the red mesh along with the regions. So I will try to make the plane on it. So I will go to plane and then select the green color region. So it will create the plane on that region. So it take the average and try to best fit the plane on that region. So we go to the sketch and then select the mesh sketch setup. And with the help of that, we can able to find the traces. Since it is a pocket, I want to, it is a rectangle pocket. So I want to find the location where I can get the bottommost length of that pocket of the rectangle. So I will try to adjust, and these traces, the blue color, the complete line will give us the trace on the plane that we have just created. So we are offsetting the tracing plane around 39.5 mm. So here it gives me the good bottom profile, and I will click OK. And now this profile has been created on the plane which I just selected for the sketching. All right, so if I go to the normal view mode, there is some obstruction of the view. So on the right hand side in the display, we have an option view clip, in which we can clip our view. So this is a plane which is created. We can just drag and move around to get the proper view based on the requirements. So I want to have this view. I don't want any obstruction. So I just check on the view clip option. So now I can zoom in and then draw the profile, this bottom profile. So I will just simply use the line command. I will also try to fix it up so it won't move. These lines won't move during the extension, and trim it off. So I want to keep these two lines parallel to each other. So I will select these two lines and right click, and I have the option of parallel constraint. So I apply the parallel constraint, and now these two side lines are parallel to each other. So I will try to view in a 3D mode to see whether these lines are really at the corner. Sometimes you have to do some estimation, visual estimation. Sometimes the tracings are not very, not always we can rely on. We have to go our manual estimation process as well. So it seems good that the lines are almost at the corner. So we can just simply close a little bit to the inside. Yeah, it seems better. All right. So it looks better. We can just simply close the profile and then exit the sketch, go to the model, and then click on the extrude. And you have option at the bottom, the cut option. It is just like a pocket to just to remove the body, remove the volume from the solid object. So we have a solid object and we want to remove it. So we go all the way to the end and click OK. And now here we have the pocket region created on this solid object. So we can also check and see, compare with the mesh data, basic visual inspection. So with the help of these features, we are able to create the auto surface solid body of the whole joystick. And we were also able to create some features, revolve features or the pocket features. And by the same process, we can create the holes, make a side holes, and so on. So the previous example was related to the auto surfacing. I hope it was helpful to you guys. It would have bring new information to your knowledge about how to make auto surfacing and what is the importance of alignment and how we can improve the mesh data. So in the next example, I will show you guys how to convert this wheel cover to a surface CAD format with the help of surface extraction method. So there are 3 to 4 different type of method for the surface modeling. One is the auto surfacing. Second one is this method, surface extraction method. Third one is the manual method, in which we have to make the manual contours and then make us surface bodies with the help of loft command, blend commands, fill up commands, like that. So in this example, I will show you guys how to create the regions, which I just created. And then I will also align the mesh data and then perform the surfacing with the help of surface extraction tools. And then in the end, we will trim lot of surfaces and then sew them together with the help of stitching, and then perform the deviation analysis. So we are again on the workspace. So let's import the mesh data. So we have this wheel cover in the STL format, and we just bring it into the workspace, and we can see the alignments are not properly aligned. We can change the color of this mesh data to different colors, but I mostly prefer to keep it as a blue. It generally showed us the default color of the mesh. All right, so to begin with the um, reverse engineering, again, we have to analyze the mesh data. We can see it is the wheel cover, and most of these features are made with the help of revolve features. So the revolve features, they have the central axis. So such type of information is very important to begin with the CAD modeling. We can see there are patterns, there are ribs, and there are like 5 ribs, and they are copied into 5 patterns in a circular way. And in the middle, there are some boxes also patterned in a circular way. So instead of going to each section individually, we can perform the circular pattern option once we have find out the central axis accurately. So let's go to the region and then create the regions first. And we have we will just select the sensitivity to very low. If we increase the sensitivity, it will, a small deviation of the mesh data will make a new region. So we don't want to have this one, since we want to make the regions as few as possible, just to get the information. So if we move around the mouse, we can see this region is the evolution. This one is the sphere. That one, previous one was the sphere as well. So that's how we divide the mesh with the help of regions. And now we will, I'll make a new planes on these regions, and I will show you the new method to align the mesh data. So the previous method was the XYZ, and in this new method, I have to work on something additionally. So I will go to the plane and then create the plane based on these regions. So this is a plane which has been highlighted, and then it shows it's a complete circle. I click on it and the plane has been created, which is average, and it is completely coincident with that plane, the region. So we have the plane one, and then we can also create the central axis of this wheel by selecting the regions. All right, so we can select the outer regions and click OK, and we will have the central axis vector 1, which is the central axis of the whole wheel. It also shows us in the right hand side in another category, reference vectors. So we can use these two information for the alignment as well, but I prefer to create another plane from the top. So I will click this plane one and go to the normal view mode. So now I am in the normal view mode of the plane one. I will go to the plane and select the draw line. So I will try to sketch a straight line as possible and try to be in the center. I did not initiate it in the correct direction. So let's try again. Yeah, let's draw the straight line, and as much as possible it's supposed to be in the center. So we have the plane created here, which seems to look at the center, but of course since it is created manually, we have to make sure that a new plane must be created, which is at the center of this wheel. So we go to the mirror and then select the plane 2 that we just created manually, and then we will select the mesh data. So first we will hide the mesh data. So the shortcut key is Control plus 2 button. So with the help of Control plus 2, we can hide the regions. And now we can select all the mesh data, uncheck the visible only option, and select all the mesh data. And we have the plane, and then we have the mesh data. Now we can click OK, and it will create the plane which is at the exactly at the center of the mesh data. All right, so we have planes, plane 3 and plane 1. We can see here under the reference planes, we have two planes. These two planes we will use for the alignment process. And we have the vector, but I'm not sure, 100% sure that this vector is completely at the center. So I will leave it there and create a new vector later on with the help of planes. So I will go to the alignment and then click on the interactive alignment and select the mesh data that we have to align. So in the moving option, we have 3 to 1. Last time I showed you how to use XYZ, and this time by 3 to 1, I will select the plane. So, and then we will select the vector, or we can also select the plane. So I select the plane 1 in the first option, and for the vector, I will select the plane 2. And for the third reference, it will be created automatically, which is at a perpendicular to these two planes. So I will click OK. And here we will have the completely aligned mesh data. So these plane 1 and plane 2 are the planes that we created, and the default planes are top, front, and right, which are now aligned, and they are exactly at the center. So with this proper alignment, we can begin with the CAD modeling process. So we can also create the central axis, as I said earlier. So we have the one vector which is available, but not 100% sure whether they are exactly in the center. So we can use the perpendicular planes and go to the, we will delete this vector 1, and then go to the model and go to the vector and select the right plane and the top plane. So there is an intersection of these two planes, which is exactly at the center of this mesh body. So now we have the vector 1, new vector 1, which is the central axis. So now we have completed the alignment, we have completed the regions, and also got the central axis. Now we can go for the surface extraction. For that, we have under the model, we have the wizards. There are various wizards. There is a loft wizard, there's a revolve wizard, sweep wizard. We have also the extrude wizard. So it automatically creates the profile and then generate the surface or the solid. So we go to the revolve wizard and then select the region on which we want to extract the surface. We select this region for time being in the first process. and the outer regions. And for the central axis, we have already created, which is vector 1. So we click on the vector 1, and then in the result option, we have two options, solid or surface. We want to go for the surface, so it will give us the open sketch, not a closed sketch. So since we are doing the surface modeling, and this is um, in this example, it's better to use surface rather than the solid to achieve the final result. So we have this sketch being created, and also show us the preview of the revolved feature of 360-degree. We can increase these resolutions to maximum, in which we can see how the profile has been changed and try to fit on the mesh data. We can go for it, and now in yellow color we can see the outer profile has been created um, with this feature. And we can see in the feature tree we have the revolve feature as well, which is slightly different from the revolution wizard. So we cannot go back to the revolution feature command options and change the options. We have already we have only one option to do it the right way, or we can delete it and redo it. So here we have the revolve, and under the revolve we have the central axis and a sketch. If you want to modify the sketch to make it more accurate, we can modify it. So let's go to the hide all the mesh data and go to edit sketch and click on the normal view mode, and we have the sketch here. And the pink color are the traces on the mesh, and the blue color is the one which is the actual profile. So we can see this profile has been created automatically with the help of wizard. So we try to adjust it by ourselves. We need to create some radius at the corners and straight line in the middle. And so this is a tangent arc. With the help of manual sketching, we are able to get the sketch, which is very close to the original trace. Once we are sure with the sketch, we can exit this sketch mode, and then we have this profile. We can also see that the vector 2 has been created with the help of wizard. So the wizard also generated another vector, vector 2. So we want to keep the vector um, all right, so we can also check the deviation of this surface body with the help of deviation tool, and how accurate is it. The blue portion shows that the accuracy is plus minus in the negative section, negative region, and the red shows that it is above the mesh data in the positive region. We can also see these two vectors are one we created and one was created by the wizards, and there are some small difference or in these vectors. So we try to make a new the original vector 1 as a reference. So we added the revolve features command, and in the vector we select the vector 1 as a reference that we created initially by the intersection of the planes. And we can also re-verify the results that it should not be deviated too much from the match data. We must also know the difference. The actual world, there are a lot of deviation involved, and in the CAD world, everything is ideal When it is 90 degree, it is 100% 90 degree, but in the actual world there is a deviation, like it might be 89.9 or it might be 90.15. So that's why these deviations, we can compromise such accuracy plus minus accuracy in the CAD modeling, because the CAD modeling is the ideal world, and it's make a complete perfect circular body. So similarly, we extract we use the evolution wizards and then select more regions in the middle to extract the surface, and then we also select the central axis and then use a surface insert. So here we can see the sketch has been appeared, and we can reselect the regions if we are not satisfied with the sketch that just appeared. We can also increase the resolutions to have more good sketch and the profile. So we can also manually adjust these sketches. So we select the settings which are more accurate. So we have this surface created. We can edit the sketch and then adjust it on for our requirements. So we extended the lens because we want to make the sketch a little bit over to the design, because in the end we have to perform the trimming operation. So these extended surface will be helpful for us to perform the trimming operation and get the more joint and the connected result. So this inner sphere we have just created circular profile. So let's create another circular feature, and for that we select these 5 ribs and also select the central axis and then select the surface insert and see the result. So once we are okay with the result, we can go for it. So this dark yellow color shows that the surface is in the opposite direction. We can change basically the surface. It doesn't matter the surface is at the opposite direction or at the right direction, just for the visual display purposes. And at the high and at the advanced modeling, and they might have some importance in the surfacing. So we just converted reverse the direction of the surface, and now the upper surface has been shifted toward the bottom. So we want to make the extension of this inner surface, central surface, with the help of extend command. We try to make the overlap so it should intersect with the middle surface, which will be helpful for us uh, in the trimming process. And same goes with the outermost cylinder. So we can drag around the mouse and get the extension of it. So here we can see that it has been intersected and come out from the outer boundary. All right, so now if you look at the mesh data, we can see there are some pockets in the middle between the ribs. and these are created with the help of side walls. We have to generate the sides surface on these side walls. So we go to the extrusion wizard and select the surface insert and select the sides region, and here we can see the profile. It has been generated and also extended. We want to make it extend it all the way so it should intersect with the other surface bodies. Similarly, this one wall has been created. We can edit the profile as well. We can extend its length by using the resize command. In the sketch mode, we can extend the sketch. All right, so here we have this wall, surface wall. Similarly, we can create this other side wall. So we have to look at the good scan data. It should not be, there should not be any missing portion. Otherwise, the profile which is generated is not very accurate to the wall. So we this wall seems better. We select, go to the extrusion wizard and then select the surface insert. And here we have the profile. We can extend the profile all the way so it should intersect with the outer boundary surface, or also to the inner boundary surface. Similarly, in the sketch mode, we can extend the profile. So now we have these two walls, the left wall and the right wall. And I found these walls not not on the same location, but on different locations. So it doesn't matter. I just have to perform the circular pattern, and so these walls will be there together, and it will be on all the 5 sides. So I go to the circular pattern and then select the bodies which I want to make a pattern in a circular way. So I select the central axis, which is the vector 1. So I will select how many patterns are there and to what degree. So there are 5 patterns required for this one, and it should be of a complete rotation of 360 degree. And now I will click. It seems good, so I will click OK. And now we have the all the walls are there at the side of the ribs. Now is the time of um, trimming game. The trimming is a very important, and we have to perform very carefully. With the help of trims, we can able to achieve the final result. There are some important things we have to consider while performing the trimming operation. If we are using 2 profiles as a tool and trying to remove the third profile, and then the previous two tool profile must be linked together. So let's see if I use these 2 walls and I try to remove the central disk. So I won't be able to remove it. It shows that there is no result since the tool entities are not joined to each other. So I have to make a profile in which these 2 entities are joined with each other, and it shows give us the single profile, joint profile. So I will create a plane on these wall and then draw the sketching. I will draw a line, simple line, 2 lines on both sides. and then I will extend these two lines with the extrude feature command. So under the model tool tab, we have the extrude option, and then we select these lines and select the direction and how far we have to extrude these two lines. So click OK, and we can able to have these two walls joined to each other with the help of side walls. So to make a proper connections, the side walls, the two walls must be coincident or completely intersecting with the side walls. So I will intersect these. Also extend these just to make sure that they are intersecting with the side walls. Now I will perform the trimming operation, and then join these profiles will be joined to each other, which we will use for the trimming operation. So I go to the trim surface. I will select the tools entities. I will remove the target and select all the entities that I want to perform the trimming on. So I will select those regions which I want to keep in the remaining bodies, only the inner wall and the side inner wall. So we have this trim portion which is a single joining body right now. So if we select this sew option for stitching them together, it shows us the complete body as well. We can also perform once again to make sure they are all joined to each other. The red region, the red edges shows the boundary. So we have to make sure that there is no intersection of red boundaries. All right, so now we have these walls joined to each other with the help of side walls. We can perform the circular pattern on these joined walls and then start the trimming process. So with the help of circular command, circular pattern, we are able to achieve the circular pattern of these joined walls. And now we can begin with the trimming operation. So to begin with the trimming, I go to trim surface and select the tool entities. So which portion I have to select. So first the middle disc, I want to make a trim with the outer and inner surface. So we just need the inner surface and in the remaining body. And now the middle disc has been trimmed. We will unhide the circular patterns of the walls that we just created, and then use these walls for the framing process of the central disk and the inner disk. So we go to trim, use these walls as tool entities, and we will select the target as a central disk and select those regions which we need to keep. So we can see the central disk and the middle portion, the ribs, walls have, the portion between the walls have been removed of the central disk. We again select the trim tool and select the joint walls, and then select the target body as a central body and select those regions which we need to keep.
With the help of this, I think the trimming method we just selected, the tool entities are um, not correct. So we have to select the central disk as well to achieve the desired results. Yeah, so this is what we need to achieve. Yeah, now we have performed the trimming operations, and step by step we are reaching to the final result of a wheel cover. It looks like that, and we can see they are also these profiles, these spline profiles at the outer edges there. First of all, we have to here remove the walls height as well. So again, we use the trim command, select the appropriate tools and the target bodies. And select the top regions of the walls. Once again, we select the trimming tool and then select the desired tool entities and the target bodies to achieve this result. We want to keep the bottom portion of the walls, so we can see how with the help of trimming commands step by step we able to achieve we are able to achieve the desired results, and step by step we are moving to the final CAD model. So so far we have completed a lot of trim options, and now we have to generate the this another profile in this C shape and the U shape. So we will select the mesh data and go to the 3D sketch and select the 3D sketch and spline, and then start to perform the contouring manually at the outer edges. Try to achieve the close results as possible. It looks like a V shape and U shape, as you can call. All right. Similarly, basically, we want to use the loft command, and for that we must have two sketches. So this type of feature is basically made with the help of loft command. So we will also draw the 3D sketch at the bottom, exit the sketch. We can this spline, the each spline have number of points in it. So the bottom spline have had 50, so we convert to 20 to make it more smoother. Similarly, if we select the top, we can see there are many points there. We can reduce the number of points of the spline to make it more smoother. We adjust to 25. Click OK. Now we have more smoother profile, and then we use these two sketches to create a loft surface. So go to loft, select these two profiles. We are hiding other surfaces for the edge of our work for time being. So we have just created this surface. So it also shows the dark yellow color. We will convert the direction. So we move the surface up and downward over the downward. We use the extend command to extend the legs of this surface. also extend the height of it, and also at the bottom. We are extending these just to use the trimming commands, so the surfaces are linked to each other properly. So now we can create the circular pattern of it based on the center reference axis. So we go to circular pattern, select the bodies, and select the rotational axis, and how many instances we want. Click OK, and we have the patterns as well. Now we perform the trimming operation. We will unhide all of the surfaces. So go to trim, select the tool entities and the target bodies. And then we want to achieve the middle section of it. Similarly, once again, we go to the trimming, select the tool entities. So as I said, it is the game of trim. We have to perform the trimming operation in a sequence way. If we little bit go wrong with the sequence, we won't able to achieve the final result in a quick way. So now we have to trim the legs of the surfaces. Uh, the surface we have just selected, so we can unselect this surface. All right, go to next step. And then select those regions that we want to keep. All right. So now this wheel cover looks like the actual mesh data is quite close to it. There are some profiles left, especially at the middle, and almost 80% of it have been completed. So we can focus on the middle section. If you want to sweep or stitch all the surfaces together, we can see there are some red edges that are intersecting with the surface. So we have to perform some trimming operation at the bottom to the outer circle of this wheel cover. So we select these walls, all of these walls, and then select the outer surface. So let's focus to the middle portion. So we go back to the wizards and select the revolution wizard and select the central sphere. For that, we also select the central axis and then make it a surface insert and check the profile we just created. So increase the resolutions and then click OK once we are good for it. So we will extend the sketch as we did in the previous profiles. to make sure that these are intersecting with the rest of the surfaces. So we will use the trim command and then trim it, which will make a good connected surface. So we resize it and then extend the profile and then exit the sketch. And then we have this spherical surface in the middle. So we reverse the direction of it, and now we will apply the trimming command and keep the center portion, and then also apply the trimming command on these central ribs based on the central sphere. So now the only things left are these boxes that we have to create, and then apply some fillets at the corner or at the edges. So we can create these type of boxes with the help of surface primitive. We go to surface primitive, extract the specific shape, and then extend the ratio. Like extend, if we extend the length and height of it. So it just created the plane surface. We try to extract the plane surface once again on the sides and do the same procedure for the front and for the right side. So let's hide all of the mesh data and just focus on these surfaces that we just extracted, apply the trimming operation in order to achieve the box shape result. So go to trim and uncheck the target and click all the surfaces, and then just select those regions which we needed in a box shape. All right. So that's better. Click OK, and we have this box with us in the middle. All right, so we have to perform some trimming operation on this box just to make sure that they are correctly joined with the other surfaces. All right, so we have this box, and now we want to make a circular pattern of this central box based on the central axis. So we go to circular pattern, select this box, and then select the rotational axis, which was a vector 1. We want to create the 5 profiles, and here we go. We have the inner boxes um, all converted into the CAD model. So there are some touch-ups left in the final results. We want to sew these one, stitch them together, and we can see at the bottom there are some extended walls and the profiles, and we can also see in the middle there are some boxes which are intersected with the surface. So we have to perform the trimming operation there. So just close the sweep command here, sorry, the stitching command here, and then apply the, yeah, since it is also intersecting, we cannot apply the stitching command here. We have to perform the trimming operation first in the middle. So let's go to the trim surface and then select the spherical surface in the middle, and then we have the boxes. We select the boxes, 5 boxes, and the center spherical surface. So let's apply the trimming command, and then we want to achieve the center portion only. So here we can see there are some other sides left. We also apply the trimming surface command with the target tool, target bodies as the outer surface, and then click OK, and then select those regions which we want. All right, click OK, and here we have Now we can apply the stitching command or sewing command to the whole CAD body. And now this CAD body is going to be a single surface joint body. There are some touch-ups left which you guys can perform, such as the fillets at the edges. We can also see the continuity of the surface in the end. And since these surfaces are not tangent to each other, so we can see these strips there are disconnectivity among each other, and we can also see the deviation analysis, and we can see the green portion which have the accuracy of plus minus 25 and the red small region shows that the solid CAD model has been deviated from the mesh data. So we can readjust the fillet size. These sizes might be bigger. That's why it's showing us the red regions. Sometimes we can compromise. Sometimes we have to remodify such small features. So so guys, thank you so much for your time. I hope you guys have learned a lot about the reverse engineering and how to use the how to get the data with the help of 3D scanner, convert the point cloud data into mesh data, how to modify the mesh data based on the requirements, and then use the auto surfacing command and to get the solid body, and then also apply some feature on the solid bodies. And we also learn about the how to extract the surface with the help of regions, how to make the alignments. So these are the basic tools and that are necessary for the reverse engineering process. And these days, the world is moving toward these type of technologies with the help of 3D scanners. So I hope you guys have learned a lot with this webinar. If you guys have any questions, I hope our team members have responded to you guys regarding the CPD points. And if you guys have any other question, you guys can email to us, and I hope we will respond you back on time. Thank you so much for your time, and Assalamu alaikum wa rahmatullahi wa barakatuh.